For the given system, let us find the force exerted by ring on a small element of rod like this. Field due to ring at this point will be equal to this term. So the force on this small element will be equal to this term. Total force exerted by ring on rod will be equal to the integral of this term. Note that we could also consider the force exerted by the rod on a small section of ring. Field due to rod at this point will be equal to this term. For various sections of ring, these components will cancel out each other, and these components will add up to produce a net field equal to this term in this direction. So the net force will be equal to this term. Which is the same as the force exerted by ring on the rod. This is expected from Newton's third law, as the net force on rod by the ring will be equal and opposite to the net force on the ring by the rod. Now, to find the increase in tension in the ring, let us consider a small section of ring like this. Component of force due to rod on this section in the plane of the ring is equal to this term. Tension in the ring increases. To balance this component of force, resolving tension into components and considering forces along this direction, we have this equation. Solving this equation, we get the increase in tension. Now, this increase in tension produces an additional stress in the ring, causing it to stretch. The additional stress will be related to the additional strain by this equation. Solving this equation, we get the increase in length of ring, from which we can find the increase in its radius.